Welcome to my front-end banking application. The home page consists of a navigation bar and a card containing a title, welcome message, and picture. Before logging in, the user does not have access to the deposit, withdraw, or all data pages. For the Create Account page, I will go over examples of incomplete submissions to demonstrate the input validations. Error messages will be displayed for the following incomplete submissions. If the user enters their name only. If the user doesn't enter a valid email address. If the user doesn't enter a password. If the user's password is less than 8 characters long. If the user doesn't re-enter their password. If the user's re-entered password does not match the initial password. If the user doesn't enter their name. Once all the fields are completed with valid input, the user receives a success message and can either add another account or log in. The login page form includes authentication as well as validation. After creating an account, the user can immediately log in using their credentials they just provided. I won't walk through all the validations for the login page, especially since some validations are exactly the same as the Create Account page. But one thing to highlight on the login page is the authentication validation, which involves verifying whether the entered email and password match any stored user credentials. If a match is found, the user is considered logged in. If no match is found, the user receives an error message indicating invalid email or password and is prompted to try again. For example, if a user tries to log in without setting up a bank account. On the other hand, Jane Doe can log in after creating her account. So upon pushing the login button, the user will receive a welcome message stating that the user is logged in. For the deposit page, here are a few examples of invalid input to demonstrate the validations. An error message will be received if the input is null, not a number, or not a positive number. So for no input, not a number, or a negative number, the error message does not change because all three are invalid. If the user inputs a valid amount, the balance is updated and a success message is displayed. So if I make this positive, deposit, okay, and that worked. For the withdraw page, here's an example of an invalid input to demonstrate the validation. So I won't be walking through all the validations for the withdraw page, as many of them are similar to those on the deposit page, with the main difference being that they apply specifically to withdrawal operations. One thing to highlight on the withdraw page, because it differs from any deposit validation, is ensuring that the withdrawal amount does not exceed the user's current balance to prevent overdrawing. If the withdrawal amount is greater than the user's current balance, an error message is displayed. Okay, so insufficient funds. And if we change it to a value less than the balance, okay, and that works. The all data page consists of a bootstrap style table card with the names, emails, and passwords of all users. The clear button can be used to clear this table if needed. The new user data is stored in the user's state array. And as you can see, the all data page accesses the user state array to dynamically render this table, which lists all user data, except for Mickey Mouse, who was predefined and hard-coded into the source code for initial testing. The user's data is temporarily shown in this table until the user logs out. Okay, so we're back at the home page, but I just wanted to share with you some challenges, design decisions, form integration, and some extra features that I implemented. I faced challenges in data flow, state management, and error debugging all throughout the app, but especially when integrating user authentication because it required careful consideration of how user data is stored and accessed throughout the application. I overcame these obstacles by consulting online resources and collaborating with peers, and learned, in short, user authentication related state, including user credentials, is managed using React Context API and the front-end code. For design decisions, I enhance styling using Bootstrap for visual appeal and responsiveness across devices, and made significant UI changes and adjusted authentication and context management to meet evolving project needs. I went with the form integration approach for my app, and I made a form component to handle the forms job and make it easier to use throughout different parts of the app. This keeps the forms behavior consistent and makes it simpler to maintain because all of the form-related stuff is in one place. Plus, it helps keep the code organized and easy to understand by keeping form-specific things separate from everything else on the pages. Using a form component makes the app more flexible and easier to work with in the long run. For extra features, I implemented login, logout functionality with error handling and protected routes for authentication, and added deposit and withdrawal logic for managing user account balances and transactions. Looking ahead, I think I will refactor my baking app to build a backend as part of my capstone project at the end of the course.